Alrighty, so day 2 in our area unit, we're now going to be looking at area of trapezoids, rhombi, and kites. Again, you might be familiar with some of these formulas, or they might just be completely new. We'll see. So, area of a trapezoid, this one is a little bit more complicated. What we need to do is we're going to add together the bases, the lengths of the bases. So base 1 plus base 2 times the height divided by 2. And the height is the distance between the two bases. Okay? The reason this formula works is if I were to draw in, because I always like you guys to see some of the y. If I were to draw in my mid segment here of this trapezoid, and if I were to swing that bottom part down here and connect it, it would look like this, creating one big parallelogram. And just so happens that the height of that parallelogram is half of what the height used to be, and that the bases would be what happens if we add these two bases together. So that's where it comes from. Now let's use it. So if I look at my first example, we see a radical in there, but that's no worries. Okay, the height is perpendicular to the bases, so here in red, those are the two bases. The 12 and the 12, I don't care about those. Those are the legs. Those aren't going to help me with my area formula. So the area of this trapezoid is going to be base 1 plus base 2. Got to do that first, because that's going to be the whole base, multiplied by the height, divided by 2. So, I lost my calculator. Where'd it go? There it is. So, I do 8 plus 16. I'm going to get 24. I'm going to multiply that by 8. So, this is going to be on top, 192 square root of 2 divided by 2. So, then I can simplify 192 divided by 2. I can simplify that part right there. And I'm going to get 96 square roots of 2 feet squared. Okay, since that one's a nice one to keep exact, I'm going to keep that one exact. All right, now let's get into the next one. 4, we know this is the height. 7, we know that's one of the bases. We need to figure out what this second base is. Okay, so pause this and try to think if you can, how am I going to figure out what that base is? So after brainstorming, hopefully you pause the video and try to figure it out on your own, because this is definitely an honors type question. What we can do is I'm going to carry that height of 4, I'm going to carry it over here. What that does is going to break this up into a rectangle and a triangle. So I know this part of the rectangle, I know that's going to be 7 feet. Now I need to figure out this part of the triangle. Okay? Well, I know this is a right triangle, so if I set that up separately, 5, 4, I can use Pythagorean theorem in order to find out one of the side lengths. And after doing that, you're going to get A to be 3. So if this part is 3, that means that the whole second base is going to be 10. And that's going to be base 2. So running out of room, but I can squeeze this in. Area is going to be base 1 plus base 2 times the height divided by 2. So area is going to be 17 times 4 divided by 2. Area is equal to 68 divided by 2. Squeeze it in right at the last second. Area is going to be 34 feet squared. Okay, so sometimes we got to do a little bit of work before we can just plug right into the formula. Okay, let's go on then to area of a rhombus and area of a kite. So both of these have the same exact formulas, and you may remember that the diagonals in both of these, and that's going to be the first star, diagonals are perpendicular. They're perpendicular in both of these figures. All right? And because they're made up of triangles, if we found the area of the triangles and added them all together, what's going to turn out to be the case is that the area formula of a rhombus and a kite is diagonal 1 times diagonal 2 divided by 2. D1 times D2 divided by 2. Okay? Remember that the diagonals of a parallelogram bisect each other, so that's going to exist within the rhombus. That might be helpful. And remember, in a kite, the longer diagonal bisects the shorter diagonal. Okay? And because they work in a rhombus and a kite, they work in that one figure that takes all the properties from everything else, that figure being a square. So if you have a square and you've got stuff with the diagonals, you don't need to try to find the side lengths in order to find the area. You could just do D1 times D2 divided by 2. Okay? So let's go through these problems. So if we've got that this part is 8, that means the whole segment, QS, which I'm going to call D1, 8 times 2 is going to be 16. And if RT, if this part is 11, then RP, which is going to be D2, is going to be 22. So to find the area of this rhombus, I'm going to take D1 times D2 divided by 2. Just plug that straight into my calculator. 16 times 22 divided by 2. And the area is going to be 176 centimeters squared. All right. Time for the kite. So we know if this part's 3, then this part's going to be 3 as well. But just like in the trapezoid, we have an issue where we don't know all of the second diagonal. But what we do have is a right triangle here. That I can set a Pythagorean theorem for. And when I do that, I'm going to figure out that that part of the diagonal right here is 4 after doing Pythagorean theorem. So diagonal 1 was 3 plus 3 or 6, and diagonal 2 was 4 plus 10, which is 14. So the area is going to be 6 times 14 divided by 2. And that's going to give me an area of 42. I don't have any units, so I'm just going to use u squared. Okay? All right, so last problem for this video. Find the area of a rhombus with vertices. So plot the points as I do the same. 1, 2, 3. That's N, P, and then Q. Okay. And I'm telling you that this is a rhombus, which helps because since I know it's a rhombus, I know the area formula that I want. It's going to be D1 times D2 divided by 2. So NQ that's going to be diagonal 1. And if I just count this is actually a little easier. I don't need to use Pythagorean theorem to find the lengths of the diagonals. All I need to do is count because it's a vertical line. 1, 2, 3, 4. It's 4 units. Okay? And we've got MP, which is a horizontal line. And that's going to be diagonal 2. It's going to be 1, 2, 3, 4, 5, 6 units. So to find the area of these figures, I'm just going to take 4 times 6 divided by 2. So area is 12 units squared. So there are 12 1-by-1 blocks that I can fit inside of that rhombus to fill it up in two-dimensional space. All right, so that wraps up this video. You'll see the next portion of the notes is 10.1 extension with everything going on. We're gonna cross those out for now. Not doing them this year. Okay, so that's gonna wrap up this video with trapezoids, rhombi, and kites. Just 2 more formulas for you to study. Start practicing those, and let me know if you have any questions. Be safe, be good.